In this tab, I'm going to go over the outdoor tab. So again, we always want to start by reading the research description. So a campus outdoor rec lab is comparing two popular workouts. So they took volunteers and randomly assigned them to do running or paddle boarding for 30 minutes. They recorded how many calories they burned. So we have a data set of 35 running sessions and 35 paddle boarding sessions. And we're going to use a 5% significance level to determine whether workout type changes the average calories burned. So this is going to be a 2-sample test. So the first thing you want to do is identify the correct test because that's going to influence everything else. So this is a 2-sample test, and the reason why is because we have a sample for paddle boarding and a sample for running. And this is going to be a 2-tailed test. And the reason why is because it says right here, we want to determine if the workout type changes the average calories burned. There's nothing here that says that paddle boarding burns more or less calories than running. All right, the null hypothesis is always the same. It's that there's no difference between the two groups. And the alternative is that there is a difference between the two groups. So if there is a difference, that means the means are not equal. And just as a reminder, for 2-sample tests, they're always going to be 2-tailed. All right, we are working with the distribution of mean differences. So we do not know a population mean. We have 2 samples. We have a sample for each group. So what we're going to do is we are going to compare our sample mean difference to a population mean difference, right? If the null is true, the population mean difference is 0. All right, so now what we can do here is we can use Excel functions to analyze our sample data. So X bar is the sample mean. N is the sample size, and we can use the count function. All right, S is our standard deviation, so we're going to use the .s version because we're working with sample data. .p is for population data. All right, our standard error is the margin of error. And it's going to tell us, okay, if the difference between running and paddle boarding really is 0, this is what the average expected difference between 2 sample means would be. So the formula for that is the square root of the variance for the first group. So we have to square it, right? This is the standard deviation. We have to square it to get the variance. And we're going to divide it by the sample size for that group. And then plus the variance for the second group. So we need to square it divided by the sample size for the second group. And then we can close our parentheses. All right, so if there is no difference between paddle boarding and running, if the difference between those two population means is really 0, if we took 2 samples of 35, on average, we would expect to observe a sample mean difference of 21.52. So if we observe a difference of 21.52, it's nothing to think about. It's just sampling error. All right, so significance level is 0.05 or 5%. Alpha is our rejection region. So we take alpha and we divide it into our 2 tails. And the reason why we're dividing it into the 2 tails is because we're doing a 2-tailed test. Now we can use the t.inv function to figure out the critical values or the t-scores that mark our rejection region or alpha. For this test, the degrees of freedom will always be computed for you. All right, for the upper or the right, we have to do 1 minus, and then the degrees of freedom. All right, now our formula for the raw cutoff. So again, that is the same as the previous test. It's the population mean plus the standard error times the critical value. However, again, our population mean difference under the null hypothesis is 0. So we don't need to add a 0 to our formula. So we're just going to do the standard error times the critical value, the t-score. Same thing here, standard error times the t-score. So if we observe a difference of 42.96 or more extreme, that's when we'll reject the null and say, okay, there's a true difference between these two groups. All right, what we're going to do here is we are going to compute the raw mean difference, which is the x-bar for group 1 minus the x-bar or sample mean for group 2. So we observed a sample mean difference of 42. The average difference would be 21.52. So we want to see if this is big enough, if it meets our cutoff. So in raw, it needed to be 42.96. So it's not reaching that cutoff. Let's go ahead and compute our test statistic. So that is the sample mean minus the population mean. So for this one, it's the sample mean difference minus the population mean difference, which is 0 again. So we don't need to add that to the formula. So we can just do the sample mean difference divided by the standard error. I got negative 1.95. And now for our p-value. So our test statistic is negative. So again, remember when you're doing a two-tailed test, you need to determine whether you're going to do 1 minus t.dist or just t.dist. And the version that you go with depends on whether your test statistic is positive or negative. So ours is negative, so we're just going to do t.dist. So we have our test statistic, then our degrees of freedom, and then true. I got 2.76. All right, so for the p-value approach, our p-value is larger than alpha. So 2.76 is bigger than alpha. So that means we are going to fail to reject. Now, what about the critical value approach? All right, so for the critical value approach, what you do is you plot your standardized critical values, those t-scores of positive and negative 2.0. So I am plotting my standardized t-scores. They're right here, positive and negative 2.0. And then I'm going to plot my test statistic. If my test statistic falls in these tails, that's the rejection region, right? These critical values mark the rejection region. So if my test statistic falls in these tails, I'll reject the null. If not, I will fail to reject. All right, my test statistic is this value right here, negative 1.95. And that is not in the rejection region. So I am going to fail to reject. So my test statistic does not fall in the rejection region. So again, based on both the p-value approach and the critical value approach, I'm going to fail to reject the null hypothesis. Anytime you fail to reject the null hypothesis, there's no difference between your groups. So you failed to detect a difference. And yes, there is a difference between their sample means. Again, we're always going to expect some difference between their sample means, at least probably a difference of 20 or so. But the test told us that this is just the difference that we observed is just due to sampling error, and their population means are the same. All right, the last thing we're going to do is the confidence interval. So we need to compute the margin of error. So that is a upper two-tailed critical value, which is 1 minus alpha divided by 2. You have to use the full alpha if you're going to do it this way, and then the degrees of freedom. If you wanted to, instead of doing this function again, you could just reference 2.0 because this critical value is the same, right? It's the upper or right two-tailed critical value. And then we're going to multiply that by our standard error. Right, so we're going to take our sample mean difference, and then we're going to use that to build the lower bound, which is the sample mean difference minus the margin of error, plus, and then for the upper, it's the sample mean difference plus the margin of error. And I got negative 84.96 to positive 0.96. So we are 95% confident that the difference between paddleboarding and running is anywhere between about negative 85 calories to almost 1 calorie, the difference between the two groups. So again, we are estimating the population mean difference. And you can notice that our interval includes 0, and that is because there is the possibility that there is no mean difference. And that is why we failed to reject. That's why we concluded that there is no difference between the two groups. And then our estimation for the population mean difference, of course, is going to include 0. All right, this is it for the outdoor tab.